All right. Good morning, everyone, and welcome to the second day of AWE. We are a little bit late getting started just because the keynote ran over. But we're going to start off today, very exciting, an AR design workshop with Mr. Mark Billinghurst from the HIT Lab in New Zealand. And of course, anyone in the AR space knows this gentleman here. So I'll go ahead and let Mark take it over. Enjoy.
Great. Thanks a lot. Well, it's great to be here. Can you switch over to the Mac? Perfect. So thank you. I've got a lot of content, and actually it's going to be too much content to convey in just 20 minutes or so. So what I want to do is I want to pass around a little book with, and if you want to get all the slides I'm going to show, as well as videos, and also reference some academic papers, and I'll give you copies of the papers, just put your name and email address down here, and I'll send it to you after the conference, so you can get all the material I'm showing as well. So let me just pass it. Can you pass it around? Thank you so much. So, as most of you know, my name is Mark Billinghurst. I'm the director of the HIT Lab at the University of Canterbury, and I've been doing augmented reality for about 18 years now. So, I've had a lot of experience in designing and developing different AR systems and tools for building AR systems. So, what I'm hoping to convey today is a little bit about how you could build systems like this, or maybe futuristic systems like this. And I guess the take-home message to show you up front is that if you're trying to develop AR systems, there's a really good need for good design. If you go down to the exhibit floor, you'll see lots of different AR technology there, and some is well done and some is not quite so well done. And part of that is because you have good designers who don't understand engineering, or good engineers who don't understand designers, and so there needs to be a bit more interaction between the two. So this is kind of my Designing AR 101 take-home message, is that you really need to know the technology, you need to design for user experience, you need to follow good interaction design principles, consider all the design elements, and then finally know future research directions. And as I said, I'll skip through these briefly, and those of you who want to get kind of the full version, put your name and email address down that little book going around, and in the next day or two I'll create a Dropbox and put everything on there so you can upload it as well. So first of all, let's talk a little bit about knowing the technology. Most of you know this kind of basic definition of augmented reality from Ron Azuma that really combines three key things, combining real and virtual images, it's interactive in real time, and it's registered in 3D. Lots of people say things are AR when not really AR. So for example, Steve Feiner last night gave me an example of somebody at the New York AR meetup who said to him, well, if I put a PowerPoint slide on my iPad, isn't that an AR experience? And Steve says, well, no, that's really a PowerPoint experience, not really an AR experience. So it's really important to keep these three things in mind when you're building for AR. There are lots of things shown at AWE, and some of it is AR and some of it's not AR, but which is fine. So AR's come a long way. In the 70s, you had this science fiction view of AR from Star Wars, and then 20 years or 30 years later, you have a live demo of that in the CNN Barack Obama election campaign. And it's also important to put AR in the context of this mixed reality continuum, where AR really exists in the middle of a whole continuum between interfaces that purely exist in the real world to interfaces that try and replace the entire real world in virtual reality. So when you're designing for an AR experience, you've got to think about where your experience is going to sit in this continuum. How much of the user's environment are you going to augment? So in building that AR experience, you can go back to Ron Azuma's definition, and you can use that to talk about the technologies that you need to use. So, if you're going to be using combining real and virtual images, you need some sort of display technology. If you're going to be interactive in real time, you need some way of inputting or providing interactive technologies. And if you're going to register content in 3D and have virtual objects fixed in the real world, you need some way to track people. So as a designer, you need to be able to have some basic understanding of these three areas if you're going to combine them together and provide a good user experience. So I won't talk about this in detail, but just to skip through, there's a wide variety of display technologies from head mount to handheld to even projecting on buildings. Ramesh Raskar and Oliver Bimber wrote a fantastic tutorial about that, and this is their taxonomy, everything from contact lenses in the eye to be able to project out into the space. And as a designer, these are all the options you have available to you. Similarly, there's a wide variety of input technologies. You can use real tangible objects all the way through to gloves in space and hands in space and device motion and so forth. And there's also a wide variety of tracking technologies ranging from satellites in space down to pieces of paper you can look at and track off. So of course as a designer, you don't need to know the intimate technical details of all these elements, but you just need to know what is technically possible and which elements you might want to combine together in your system. One of the important things you do need to understand, though, is how to design for user experience. And when Venkat Ramaswamy wrote this really great book called "The Product is no longer the basis of the value of the experiences," and you see that in a lot of consumer products today. Is that, I went to a trade show in Germany about 5 years ago, and there was a whole hall of Taiwanese manufacturers making MP3 players, and they all look the same. So when you've got 200 MP3 players, how do you decide which one you're going to get? And it's going to be based on the experience. Gilmore and Pine wrote this book about the experience economy and talk about how companies move up the value chain depending upon what they provide to consumers. So the ones at the low end are providing basic components, and in the IT space it's resistors and capacitors, and the ones at the top end provide very rich experiences. So Disney takes those resistors and capacitors and combines them into theme park rides that ski your pants off, and you pay a lot of money for that. And that's because the engagement with the technology changes from a functional engagement to an emotional engagement. And that's the same for AR design. Currently many companies are providing lots of components, but few people are really combining them together into compelling AR experiences. So in a similar way, you can build a hierarchy of the type of things you need to have to design a compelling AR experience. You need to have an understanding of basic technologies. You need to be able to use some authoring tools to combine those technologies together. In the application space, it's really about interaction. In the experience space, it's really about usability and user experience. So a little simple example I often share about that is coffee. If you go to Kenya, you can buy coffee, a kilo of coffee for maybe 20 cents. You come to my house and I make you instant coffee for 50 cents. And you go to Starbucks and you pay $3.50. Because at Starbucks you get the nice comfy chairs, the free Wi-Fi, the magazines, the music, and the barista makes you a beautiful coffee with a love heart on the top of it and everything. So you pay lots of stuff for experience. Another more technical example is when I was in Korea a few years ago, I came across this company called Reactrix, and they had this projected display, projected image on the floor of a big shopping mall. So the idea was there's no instructions or anything. You walked on this projected image, and it reacted to you automatically. And what happened was the graphics changed depending upon what you're doing. So let me show you a little video of this working. There are many examples of that they showed, and the one was a car game. So in this case, you can see my friend Ben, and he puts his feet on the ground, and these little cars race around, they crash into his feet. Or in the second case here, you've got the Coke example. So you walk on this big ice sheet and it cracks, and you can see the Coke logo below, and these little Coke cans being kicked around. And even that little boy at the back who's 18 months old, he kind of is enjoying it. So of course the advertisers love this because, the parents love it first of all because they can bring their kids to the mall and they can play and have a good time. But the advertisers really love it because normally you walk past all the Coke advertising, and now kids are playing with their Coke, and they're learning from a very early age that somehow Coke equals fun. So I talked to one of my friends who's a computer vision guy, and I asked him how long would it take him to build that, and he said, about 2 weeks. It's very simple technologies, background subtraction, and this is before the Kinect or any complicated depth cameras, just background subtraction and a bit of graphics. The company that did that wrapped a really great user experience around that simple technology, and they raised $27 million in venture capital funding, and delivered this to 3,500 malls all over the world. So simple technology, great user experience, you can get out there. It's the same with AR as well. Sometimes I ask people, if I offered you for a head-mount display for $400, would you take it? And many people say, oh, sure. And then I show this slide and say, well, what happens if it looked like this? And so sometimes when we're designing user experiences, we have to think about all aspects of the user, and we don't necessarily consider that. So it's not just about the physical aspect and being able to engage with the technology, but it's also about the emotional and cognitive, and most importantly, the social and cultural aspect. And you're seeing that a little bit now, the Google Glass display that's being developed and worn around a little bit at the conference here. That's a pretty unobtrusive display, but it still has some social implications. And of course, it's a lot less obtrusive than the big dome I just showed you before. So as a user experience designer, you've got to think about not only how people use your technology, but where people are using their technology in the social and cultural context. So here's a range of typical AR experiences. There's web-based experiences, outdoor mobile experiences, handheld, location-based. When you're building good AR experiences across this range, you need to think about several different things. So, for example, first of all, you want to make the experience compelling. People like the Coke example. They want to engage with it. There has to be some sort of magic moment that captures people's attention. It has to be intuitive and usable, of course. And in most cases, it should use people's existing skills. Children know how to walk and kick, so they play with the Coke thing. And because it's an AR experience, it should really be anchored in the physical world some way and provide a seamless combination of real and digital. So let me show you a little example of experience we've been developing at the HIT Lab, and we've just made it available so you can try it for yourself. Can you swap over to the iPad, please? Hopefully this works. I'm always a bit nervous about live demos. Oh, there it is. It's fine. See all my secret icons, but let's see here. Okay, here we go. So this is a colouring book experience. Okay, there we go. And the basic idea is that you can take pages and then you can colour them in, and you can create custom 3D content from the pages. So if you're a kids book author, this is fantastic because you can build colouring books kids can author with. If you're a brand and marketing person, this is a Nike shoe. I can download it from somewhere, colour it, and design my own shoe, and take the photograph and send it back to Nike. So let's try that. What was your name again? Paula. Okay, great. So I'm going to make a shoe for Paula. So first of all, I'm going to write Paula's name on the corner. And what's your favourite colour? Purple. Excellent. You're in luck. So I'll give you some purple colour here, a bit of red highlighting, and some yellow up here. I'm not a very good colourer, but you get the idea. And maybe some orange laces. And because you're going to run fast, we're going to put a lightning bolt on the side that's in blue. So there's Paula's really badly designed shoe, but so please don't get me to work for Nike, but that's the shoe. And now what I can do is I can look at that with my iPad, and it will create a 3D model, but it will apply Paula's textures onto the model. So here we go. And you just have to hold for a second. And now you see the shoe comes to life. And there it is. And it has a little animation and dances around a little bit, and that's oh, thanks. I should applaud my students, not me. But you can see this is quite a compelling experience because it engages the user. It's also customizable. You can build your own thing. And it uses, of course, it's connected to the real world, and it uses people's existing skills. People know how to colour and draw and everything like that as well. So this is just a new app that we've just developed. Can you swap back to the Mac? There we go. And if you want to, you can try it yourself. You can go to the iOS. It's available right now, and next week it'll be available on Android. Or go to this website and you can download it. It's for free, and you can download blank pages and colour them in. Or I'm showing it at the exhibit hall later on today. But you can see from this, it's quite a compelling experience because when people try it for the first time, they immediately want to go back again and colour some more, add more content, and it uses the skills that they've already got, and it's anchored in the real world. So, let's see. Okay, great. So I'm going to talk a little about following good interaction design principles and then skip through at a high level some of the other things as well. So interaction design is really the design of user experience with technology. So you have to answer these questions. What are you going to do? How are your actions going to affect the world? What do you feel? So how does the world react to you? And then what do you know? The most important thing is to keep this process in mind. It's about discovering user needs, designing for those needs, and then evaluating for those needs. And it turns out some people in the AR field are really good at doing the design part, but sometimes not so very good at discovery or at evaluation, unfortunately. So in terms of AR user interface design, here's a few guidelines. You need to think about what your user is, who your user is. There are a lot of really good HCI or interface principles we can adapt from other areas and bring them over to AR. So for example, if you're developing a mobile platform, of course there's a wealth of material about how to design interfaces for mobile devices that you can use and tell you how big to make the icons and all that kind of stuff. You also have to consider the device constraints, use design patterns, which is quite a new approach in the AR field, and then think about your interface metaphor and evaluation. So let me talk about those just a little bit. So if you're doing a mobile AR experience, you have to go back to thinking about the physical, the social, the emotional, cognitive use of the device. So if somebody's doing a mobile AR experience, they're probably mobile, they're probably using one hand, they need to be able to multitask, they might be using indoor outdoors, they need to interact with the real world, and they will probably want to use this very short application use. So you've got to think about all the uses of how they might use the mobile AR case. There's some quite interesting differences between AR and non-AR design. So with non-AR devices, screen-based devices, oftentimes the digital content you're showing is mainly 2D, mainly virtual objects, and mainly explicit interaction. Whereas with AR, you're oftentimes showing 3D content and you're trying to connect back to the physical world and physical interaction. So as an example of that, you can contrast between showing points of interest and navigation on a map versus points of interest on an AR system here. So Google Maps is mostly 2D or mouse or finger driven, text heavy, it's kind of an exocentric view, whereas with the Genio AR interface, you've now got this 3D content shown, it's egocentric, and it's a very simple simple graphics. Let me just skip through this a little bit. Well, I can say a couple of words about this. Obviously, it's important to design to the device constraints. So if you're doing a handheld AR, you've got to think about how can people use the device one-handed. The tracking may be slow, so how can you develop an application that doesn't encourage fast actions and so forth. One of the more interesting areas that's just emerging, though, is using a design pattern. So design patterns is a quite well-known technique for people designing user interfaces and other types of objects. So the basic idea is you consider a problem that people encounter over and over again, and you design a pattern to overcome that problem. So, for example, Yahoo has a really great website where you can go to, and they provide a bunch of design patterns for web design interface. If you want to have a pull-down menu, or if you want to have a selection box, something like that, Yahoo provides design guidelines for that. Well, similarly, in the AR space, we're starting to see design patterns happen. So, for example, Blair McIntyre produced a great paper that talks about handheld AR design patterns. One of them, for example, is seamful design. So integrating, when you have an AR experience, sometimes you have these technology seams. So, if I've got my handheld AR experience and the tracking fails, then maybe something, there'll be a break in the experience, or there'll be some technology seam as a result of that. So because of that, you need to design around that, or you may want to have an experience that encompasses some sort of living creatures, so you want to have creatures that then respond to actions in the real world that makes them more believable. I don't have time to talk through all of this, but as I said, if you put your name on the paper there, I can send you a copy of the paper and you can read it for yourself. But there's a couple of examples of that. This is one example of a seamless design. This was one of the winners in 2 years ago. I think Qualcomm had a competition where they asked people to use the Vuforia library to build AR experiences, and this was the winner. And this is a game called Paparazzi, and the game was to take photographs of this guy and pretend you're a paparazzi. So you looked at this tracking pattern, you'd see the guy in the pattern, and you start taking pictures with your camera, and you got more points for the closer you got to the guy. But as you take more and more pictures, he gets more and more annoyed until eventually he jumps up and he starts to grab the camera from you. But when he jumps up and grabs the camera, then what you're supposed to do is shake the camera to get him to let go. But when you start doing that, that causes the AR tracking to fail. But what they did, which was really nice, is that once the virtual character is attached to the camera, it no longer uses the AR tracking, it uses the inertial sensors in the camera to provide a seamless experience. So let me show you a video of that working. Let's see here. So you'll see, here's the paparazzi, the character, and then you can look, it's quite dark, isn't it? But I guess, you can see the character there. I wonder if I can get it brighter. Yeah, so there's the, oh wow, it's really bad. Okay, there's the character, and then when you start taking pictures, he's drinking coffee or something. You get points for full head shots and body shots and all this kind of stuff. So he'll take a few shots there, and you get some points for that. And then, the character starts noticing you and starts getting irritated, and then you'll see him jump up and grab the phone. You can download this game from the Android Play Store. So he's kind of looking at you now, and you're getting really close now. So he's now not looking very happy, and Now he's going to jump up and he grabs the phone and he starts swinging around. And now what you're supposed to do is sort of shake the phone to get rid of him. And of course in this case, if it starts shaking violently, the tracking's going to fail. But they've done a really nice design of seamless design, example of seamless design, where their game still works even when the tracking fails. Yeah, and if you don't get him off, you start smashing your camera and then you lose the game. So another example of following design pattern is living creatures. So Sony made the iPet game, and they have a creature that's supposed to be in your real world, but the way Sony designed it is that the creature responds to some real action. So when you blow on your handheld device, the creature has fur, and the fur starts waving depending on how you're blowing. Other examples would be if there's lights, real lights in the real world, that you can somehow cast virtual shadows onto virtual objects and things like that. So as a designer, if you want to create the illusion that you've got a real creature in the real world, then if you can have that creature responding to real actions in some way, like noise or light or sound or blowing, then it creates a stronger illusion about that. I'm going to skip through this part here. Let me just say it's really important to evaluate AR applications, and if you're interested in doing AR evaluation, we wrote a report a few years ago that summarized all the papers we could find in augmented reality, 6,000 at the time, and we wrote a detailed summary of 165 papers that had user studies. So if you want to do AR studies, please download our report, and you'll probably find an example of a study there that does something similar to what you've done. And again, I can send you a copy of that report as part of your email addresses. There's an interesting model for doing design evaluation that Jason Gabbard wrote, where he talks about how you can do several types of user evaluation, expert guided evaluation, formative and summative comparative evaluations, and those evaluations fit into the overall design context. So let me just show you this section, and then I think we'll have some time for questions. So one of the important things about designing AR experiences is that you have to consider all the design elements. Unlike designing for computer desktop interfaces, which is mostly digital content on the screen, AR involves a strong connection back to the physical element, the physical real world. And so now, instead of being a computer scientist, you also have to be an industrial designer, and you've got to think about what the objects in the physical would have to be like to interact with your system. And then most importantly, what's the interaction metaphor that connects those objects in the real world to your virtual elements of some way. So the design space actually for AR transitions or crosses over between purely physical real-world design into virtual reality. And so you have to think about the design of objects, and one of the most important elements of that is the affordances or the shape of the object. So you've got to think about affordance-led design, how you can design objects to show people how you want them to be used. A good example of that is this project on AR chemistry that Morton Fell did almost 10 years ago, in which they had very simple AR toolkit tracking on the markers, but they put those markers on different objects and used the object shape to inform how they're going to be used. So in this case, you had this paddle. You could scoop up atoms from the paddle. There's an atomic periodic array book. You could shoot the atoms over to this other area where they could be assembled to molecules, and you could use this cube to rotate the molecules and look at them from any angle. So you can see all these different input devices, different shapes, but they all use the same tracking, but to the user that's kind of invisible. So let me just show a video of that. And well, it's quite a small video, let me just put that bigger. So you can see the guy here sitting in front of it. It's a projected AR system, so he looks, for instance, on the projection screen. He can use the paddle to pick up atoms, and then he can assemble molecules. But the paddle has a button on it, and it's got a handle, so it's very obvious how to use it. So, and he's got a book there with different atoms, and of course you turn the page of the book, you can see different atoms, and there's an arrow pointing to the book saying you should pick it up, and then you can shoot it over to this little thing over here where he's building a some sort of carbon molecule chain there. And then with the cube you can rotate the round, and it rotates the molecule, so it's a two-handed interface. So it's a very nicely designed interface. Let's see. Let me just talk about a variety of interaction metaphors. The metaphor is really important because people understand the metaphor, then they can really easily understand how to use your system. And many AR applications we see right now are mostly just information browsing. You can use your handheld AR to see content in the real world, or you hold a magazine ad up in front of your web camera or your phone, you see content popping out of it, but with very little interaction. A lot of what we're doing at the HitLab is at the bottom here, which is what we call tangible AR, where you can look at how you can use physical object design principles and combine it with AR output. So let me just skip through these a little bit here. So we've done things like the Magic Book Cup project, where you can take a handheld cylinder and you can use that to pick and move objects and in the city. And in this case, the cylinder itself is available. You can do a lot of different commands with that with a single object, so picking and deleting, moving, and so forth. Let me show you a video of that working. But now you've got to think about the physical object that you're using to do the interaction. So here's a person picking up a building, and then you can stamp with the cup and place the building down, rotate the building around, and so forth. And as I said, this is a city design application, so you can pick up and you can shake, and then it will delete buildings you're holding in your hand. You can also copy, and now you can pick up and you can stamp a bunch of things on the table here. And I think you'll see in a second adding in different lighting controls as well. Okay, so now there's a virtual. This is a lever. This is supposed to be the sun. And as you put the sun down and you bend it over, it moves the sun around, and the building shadows start moving around as well. So in this case, with the cylinder, there's a number of affordances you can do, like stamping and copying and tilting. But you can see how it's mapped very naturally to the object actions. Okay, I've just got a little time left now, and I wanted to just touch on one area for future research. I've shown you examples of interaction design and how you can do design in the past. There's also, from the movies, you can see different future visions of AR, and this is a still I captured from the Iron Man 2 movie. And those of you who remember the movie, that he uses some very nice AR or simulated AR to show user interfaces of the future. And there are some future trends that can inform our design. One of the most important future trends is things like this to be in movies. And this, to make this vision really real, what you really need to have is content in displays, but also the ability to support free space hand and body tracking. So in the Iron Man 2 movie, he can reach in with his hands and manipulate content, speech and gesture recognition, and capturing the user environment. And of course, most importantly, usability and user experience. So let me just finish by showing you two videos of work we're doing that works in this area. And if you go to the trade show downstairs, you'll see examples from 3Gear and from Meta, and I think that's all. I'm using gesture input for AR. But let me give you a couple of examples here. So first of all, we've done some work on capturing the real world, which is actually I'll show you which is here. So this is being able to use depth cameras to capture real gestures and then have interaction between your gestures and the real objects. So in this case we're using it for spider phobia. So you can see this virtual spider appears to crawl on your real hand, and as we pick up and move the hand around, the spider sticks to your hand as well. And then we can take real objects and interact with the spider as well. So now our spider appears to crawl on this book, so the Kinect can capture the real world as well. And then you'll see the user interacting again with, you pass his hand over his occlusion, and there's also paper occlusion, and you can take your finger, pick the spider up a little bit, and then I think he's going to show a bit more interaction with the spider. And the spider has a little bit of AI, so it knows to stick onto your finger. You can kind of poke with the spiders a little bit as well. So we're getting to a stage now where you can do much richer interaction. So now it's just not about tracking objects, it's about capturing all the user input and providing it here as well. And this is really exciting because it means now we can take all the skills we have to interact with the real world and use that to interact in the AR scene content as well. So just to conclude, and again I'm sorry that I wasn't able to show all the slides, but I'll email them to you. So there's a need for much better design AR experiences, and this is through really the application of interaction design principles, through understanding the technology, using tools, and doing some rigorous user evaluation. There's a lot of important areas for future research, such as things like I just showed, natural interaction, speech and gesture interfaces, using more intelligent agents. If this is interesting for you, then I can answer a few questions now and before the break, and then also feel free to contact me, and I'll be down on the show floor at the Eismar booth, which is right over where the bar was last night, and I can show you live demos of that as well. So thank you very much and please, if you want to get content of everything I've showed you with videos and some of the papers I've talked about, make sure you put your name and email address in the book that's going around, and I'll create a Dropbox and email you all in a day or two, and you can get all the content. This is a subset of a much larger course I taught at CHI conference at the beginning of this month, and I can provide all material available for that to you as well. So thank you very much for your time.
So we ran a little bit over in time,
Sure,
but I do want to open it up just for one or two quick questions. So does anyone have any questions? We have one over here.
Has there been any research or thought on measuring and metrics for AR experiences?
Yes. So actually, Chris Stapleton, is sitting just right there next to you. He is an expert on how to measure and characterize AR experiences in terms of rich media experiences. There's been lots of studies on formal user evaluation, like how you can pick and move objects, and then I would say that the more subjective experience evaluation is still a hot area of research right now. You know, you want to be able to create experiences where people really get engaged and have a rich flow experience. And Chris has done a lot of fantastic work in museums and theme parks that he can talk to you about that. So, yeah.
Any other questions?
There's a couple at the front, I think.
Hi, I was just going to ask if you had any recommendations or knew of any design pattern libraries specifically for designing for head-mounted displays where you might have kind of an audio interaction with the display as opposed to mobile screen?
So I don't know of any design pattern libraries specific to that, but I do know of a number of papers that have been written about that area of research. So applying design patterns is very, very new. So the paper that Blair McIntyre wrote that I showed, that was from 2011, late 2011. So, and as far as I'm aware, nobody's really addressed specific design patterns for audio interfaces for head-mount displays. But there are quite a number of research papers being published on how to develop spatial audio interfaces for head-mount displays and how to combine audio with visuals. But they haven't yet been gelled together into design patterns. You basically have to have a critical mass of research before people can say, well, that what I discovered or what somebody discovered is actually applicable across a wide number of cases. But if you email me, I can certainly point you to some research papers in the area. It's one of my areas of research right now, or part of an area of research, so yeah.
Hi. With the arachnophobia clip you showed just there,
Sure.
has that been, is it commercially licensable?
It is. We haven't commercially licensed it yet. We're trying to get... so this is a self-funded project and we ran out of money, so we haven't done the formal, I guess, clinical trials, but there's a psychologist involved in the project and also a number of clinicians. And it looks like the clinical trials are going to happen later this third quarter of this year. There's a group in the US that are planning to do that. But certainly, if you're interested in that technology, I'm happy to talk about licensing. Actually, that's just an application of the gesture library we developed. It provides a rich range of experiences, but it's quite a unique application because people really haven't thought before about how you could use AR to bring phobia causing stimulus into the real world, and specifically spiders. So, yeah.
It looked very solid.
It is very solid.
The stability looked very solid. What were you using? Were there any commercially available tools, or was it all proprietary?
Well, the gesture library is our own, but the tracking we used was using a Kinect, and of course, PrimeSense has now new depth sensors that are even more robust, so we can provide even better results. Of course, you want to you have to wrap that all around a clinical evaluation user interface, and we've been working on that as well. So you don't just show people a spider on their hand right away. You build up to the stimulus, and eventually they can poke the spider rather than scaring them out of their wits. Yeah. So we're working on that too. But I'm happy to talk to you about that later. So, yeah.
Well, please, another round of applause for Mark.
Great. Thank you very much.
So we kept you guys over a little bit in the time, so you don't have too long to get to the next session.
You write your name in that little book, or you can email me as well, but I'll provide it all available to you. And don't walk off with the book, please.
So next in here we'll have AR impact on social and culture, and that will start in...